Greetings, students. These, I anticipate, are the notes for Monday's class. We will likely spend a couple of days looking at the theorems on the sets of angles around parallel lines. And on Monday, we will set out to discuss the converses of the parallel theorems. So let's start taking a look at that. Okay. Our objective for Monday will be the student will apply the converses of the angles theorems in order to determine if lines are parallel or not. Again, I anticipate these being the notes for Monday. That would be October the 21st. Copy your objective and the date. Anytime you need more time, just press play, or press pause rather, and then hit play when you're ready to move on. Now, up to this point, we have been using the fact that lines have been parallel in order to determine the measures of various types of angles. Now we're going to use the converses of these theorems to decide if lines are parallel or not. Now, a few weeks back, we talked about conditional statements and also the negations. One of the negations was called a converse. And if you remember what a converse did, is it took our original statement, our original conjecture, which was if P, then Q, and converse switched the P, which was the hypothesis, and the Q, which was the conclusion, switched their places. So instead of if P, then Q, we had if Q, then P. And we said that some of the strongest theorems that we have in mathematics that we're going to look at this year are going to have original statements that have not just converses, but also inverses and contrapositives that are true as well. Okay, but converses is the main one for mathematical theorems. So let's take a look at what they say. Now, the original rule for corresponding angles said if you have lines that are parallel, then your corresponding angles are going to be congruent. Well, the converse of this statement is exactly true as well. If your corresponding angles are congruent, then that means that your lines you're looking at are parallel. Okay, so we're going to look at this diagram kind of over and over again, and we will apply these converses to this diagram. So again, you can probably just copy down the diagram one time and get away with it for all of the converses. All right, now if you remember back to when we talked about parallel lines, we said there were only going to be three ways that we would know that lines are parallel. Okay, and the ways that we said that they would be parallel is they may put little arrows or triangles on the body of the lines to indicate to us that lines are parallel, and that's what we've been seeing for the last couple of days. They may tell us that the lines are parallel using some kind of external information. We haven't really seen that yet. Or the third way we would know lines are parallel has to do with math that is going on around those lines. Well, here is the beginning parts of some of that math. If we can prove that our corresponding angles are congruent, that will mean to us that our lines are parallel. So what we're looking for in the case of corresponding angles is, of course, we need to identify our corresponding angles, like angle 1 and angle 5 are corresponding, 2 and 6 are corresponding, 3 and 7, 4 and 8, just like we've been talking about for the last couple of days. And what we need to be able to do is to find any pair of corresponding angles, prove that they have the same measurements, and if we can, then we are able to make the statement that the two lines that the transversal is hitting, then they are parallel. In this case, line M would be parallel to line N. Okay, very similarly, so it'll take a little bit of less time to explain, the converse of the alternate interior angles theorem. Well, the interior angles theorem said, hey, if you start off with parallel lines, then your alternate interior angles will be congruent. So the converse is going to say, all right, if you have alternate interior angles that are congruent, then your lines are parallel. So once more, using that same diagram from the first page, Okay, we need to correctly identify where our alternate interior angles are. They would be angle 3 and angle 6, and also angle 4 and angle 5. And the converse is basically telling us if you can find any pair of alternate interior angles that are congruent, then that is going to mean that your lines are parallel. Okay, also, we talked about same side interior angles, also called consecutive interior angles. The original rule, the original theorem said that if your same side interior angles are supplementary, remember all the S's go together, same side supplementary, same side supplementary. If your same side interior angles are supplementary, then your lines are congruent. That's what the converse is going to say. So using that same diagram again, once again, we need to correctly identify where our same side interior angles are. They are angle 3 and angle 5, angle 4 and angle 6. And if you can prove in your picture that your same side interior angles, any pair of them, are supplementary, then your two lines are parallel. And lastly, the converse of the alternate exterior angles theorem. The original theorem said if you have two lines that are parallel, then your alternate interior angles are congruent. The converse says if your alternate exterior angles are congruent, then that means your lines are parallel. So one last time, using that diagram, we need to correctly identify where our alternate exterior angles are. They are angle 1 and angle 8, and angle 2 and angle 7. And if we can prove that any of those pairs, or either of those pairs of angles, alternate exterior angles, are congruent, then your lines are parallel. Okay, so it's the same rules, just a different way of going about it, has a different end application, but it's the same rule. So if you understand one, you ought to be able to understand the other one without too much adjustment. Okay, now we're going to have a look at the math that goes along with this. Hopefully you're getting a good grasp of things and you might be able to do this on your own. So go ahead and take a stab at these examples. Let's see if you can't get them. And then when we get to class on Monday, we'll do a quick rundown of these problems and make sure that you got the right answers. So copy down this diagram and give it a try. Okay, you have a couple of lines, C and D. There is a transversal intersecting them. We do not know if lines D and C are parallel or not, but we are instructed to find a value of x so that these lines, C and D, will be parallel. So what you need to do is you need to figure out what type of angles are these in the diagram. What are these angles supposed to do in the diagram based upon what kind of angles they are? Write an equation, and let's see if we can solve for a value of x that'll make our statement true. Also, copy down this one. Again, line A, line B, intersecting by a transversal. The question is, are they parallel? Okay, well, we need to figure out what kind of angles these are, and if they do not happen to be any particular type of an angle that we know about, maybe we can use another definition that we know about. Other definitions like vertical angles or linear pairs, things like that, that can also help us in order to prove our points here. And lastly, copy this example down. We got line E and line F intersecting by a transversal. We are instructed to find a value of x so that lines E and F will be parallel. So once again, we'll ask ourselves what type of angles are these? Based upon the type of angles that they are, what should their math be doing? Are they supposed to be equal? Are they supposed to be supplementary? So we can write ourselves an equation and we can solve for the missing variable. Again, give those a try in your notes there, and hopefully come to class on Monday with some solutions to that. That way, when I run over them real quick in class, you'll be able to verify if you got them right or wrong. Hope you have a good weekend, and I will see you in class on Monday.